Hello everyone. Today we are going to start our new playlist on ordinary differential equations. But before that I want you to cover some basics. So the very first thing is, what is a differential equation? An equation that expresses a relationship between a function and one or more of its derivatives. For example, dy by dx is equal to 2x. Here we are given that the derivative of y with respect to x will be 2x. Okay, so we are given the relationship between y and its derivative, that if we calculate the derivative of y with respect to x, we'll get 2x. This is the relationship between y and its derivative. Now here the function is unknown. We don't know what y actually is. We'll get to know when we'll integrate this differential equation, but right now we don't know what y actually is. We just know that its derivative is 2x. Okay, now the second thing in this definition is derivatives. Now what is a derivative? Here you have seen that we have the derivative of y with respect to x, but what does it actually represent? Why we are doing this? Why we are calculating the derivative? So the derivative is a measure of the instantaneous change of a function at a specific point. Now what do you mean by instantaneous change? So if you remember in your school time, whenever we used to calculate the change in any quantity over time, we used to write it as quantity over time. For example, if we want to calculate the change in distance over time, we used to write it as distance divided by time. But here when we are talking about the change in a function y, we are writing it as dy by dt instead of y by t. Why? Because here we used to calculate the change over a period of time. We are calculating the change over a period of time. But here in this we are calculating the change at a specific point of time. That we are calling it as instantaneous change, right? So we are calculating the change at a specific point. Or we can say, if we are dealing with time, then we can say that we are calculating the change at that precise moment. Okay, we are not calculating it over a period of time or over an interval of time. We are calculating this change over a specific point, at that specific time, at that specific moment, at that precise moment. For example, if you have observed the speedometer in your car or in your motorbikes, you can see that the needle keeps fluctuating. That means it is calculating your speed at every moment. It shows you that how fast you are moving right now. It doesn't show you your average speed. Okay, it shows you that how fast you are driving at that specific moment. Okay, that's why we are studying derivatives. Now the next thing that comes is the independent variable. So a variable that is being changed or manipulated is known as independent variable. Dependent variable, a variable whose value depends on the independent variable, is known as dependent variable. For example, your test score depends on how long you sleep. Okay, how long you sleep will affect your test score. So this can be changed. Okay, this is over you. You can change it. But test score, you cannot change it. It will depend on how long you sleep. Your sleeping hours will affect test score, but you cannot directly change your test score. You can change your sleeping hours and then your test score will automatically change. Okay, so here you can change this. That means this will be your independent variable, and according to your independent variable, your test score will automatically change. That means it is a dependent variable. It is depending on your sleeping hours. It is depending on the independent variable. Okay. Let's see few more examples. In this differential equation, you can see that we have the derivative of y, and here also we have the derivative of y. Here we have the second order derivative, and here we have the first order derivative. But we have the derivative of y only. Okay, so y is the dependent variable here. Now we have the derivative with respect to x. Here also we have the derivative of y with respect to x. That means x here is the independent variable. In the next equation, we have the derivative of u, and here also we have the derivative of u function. That means u here is the dependent variable, and we have the derivative with respect to x, and here we have the derivative with respect to t. That means x and t are independent variables. Now you can observe that in this equation, in this differential equation, we had only one independent variable, that was x, and in this differential equation we had two independent variables, x and t. So here we are given a small note that says that equation 2 is an ordinary differential equation because it involves derivatives with respect to single independent variable, and equation 3 is a partial differential equation because it involves derivatives with respect to more than one independent variables. Okay, so equation 2 is this is an ordinary differential equation. Why? Because we have only one independent variable in this equation, and in the third equation we had two independent variables, x and t. That's why it is a partial differential equation, not an ordinary differential equation. It has more than one independent variable. That's why it is a partial differential equation, and this had only one independent variable. That's why it is an ordinary differential equation. Now we'll start our ordinary differential equation in the next lecture. That's all for today. Thanks for watching.